Back in our workbench, let's go back and rename this 0 AOA for the angle of attack. Let's duplicate this section. Let's call this 5 AOA and go into the geometry. What I want to do in this particular case is bring the wing up 5 degrees. So I'm going to select the surfaces, use the move tool, move it to that component. I can align with the axes, so anchor it to here, and if I click that, I can hit 5 degrees on my keyboard, press enter. Going to our groups, you can see we've still got our name selections that we've previously specified. Let's exit this and check out the mesh. When we look at our meshing, over here, when we scoped the method to a name selection, and the name selections haven't actually changed, we should be able to generate the mesh without any issues. Looks like our mesh generated well. Just have a look through, make sure everything's looking good, and then go into the setup. Looking at our simulation, we can see that the new mesh has been brought in, so we can just hit run calculation. We can see after running 140 iterations, residuals are dropping, and we've got the force monitor that's evened out. Looking at our contours, again we can see static pressure. We've got our stagnation point roughly around the leading edge. However, it looks like we've got a lot more separation. Looking at static pressure though, it looks like the lower and upper static pressure profiles look as expected. Looking at our forces, and it looks like we're making more downforce than previously expected. In order to compare, we can bring in some results, add the solutions, and open it up in CFD Post. With CFD Post open, what we can do now is compare the two simulations. So we've got the AOA at 0 at the top and at a positive 5 at the bottom. Looking at static pressure on the symmetry, we can see that we've got a larger lower static pressure region around the AOA of 5 degrees.